Okay, so in previous lecture, we discussed till the relation between price and yield is inverse. And notice that this relationship between price and yield is actually inverse. So when we talk about price, it's inversely proportional to yield. And yield is actually, when we talk about this from the context of bonds or fixed income. So yield is actually representing a rate, and this rate is actually divided into two components, whether it's IRR or required rate. Okay, not okay, yes, required rate. Okay, required rate and implied rate. My bad. Implied rate. So IRR, implied and required, and this is what we were discussing. Implied return and a required return. This is actually what, let me just clear it up. We will not be using this. So implied return, required return, and implied growth. Implied growth of equity as well as required growth. And there is a measure to discuss. There is a measure to calculate that also. And foundation, the foundation lies on present value and the cash flow. So present value, cash flow. These are two things that you, uh, from quant's perspective, these are actually the fundamentals, the basic building blocks of uh, the whole subject actually. So this is actually how we write things when they are inversely proportional. So this means if price is increasing, yield is actually decreasing. When price is actually price increase, there is a increase in price. The yield is decreasing. And when the price is moving downwards or when the price is decreasing, so the yield, it's obvious that given the inverse relationship, yield is going to decrease. And uh, we will discuss about this in examples. Okay, yes, this example we discussed. So if you pay attention here, the price actually decreased to 1085, and the yield to maturity increased from 8 to 8.69. And the same annual pay bond we examined in earlier example, this means that this is a discount, pure discount bond, pure discount, pure discount bond. Yes, we were discussing about pure discount bond, and by now you know that when we say pure discount, this means the PMT is actually zero. All right, so required return on equity. Okay, let's the final words. Let me just so the relationship is inverse, and when price increases, the maturity. When the price increases, yield decreases, yield to maturity, and when the price increases, yield to maturity decreases, or equivalently. And we will use this concept again and again when we study bonds in fixed income topic area, and uh, it's important if you are starting from fixed income lectures, if you're watching fixed income lectures, you will be having an issue with this reading. Why we are doing this? So I will suggest you to start with quantitative methods first, and that's the sequence of the video lectures. Afterwards, we will start with FSA, financial statements and analysis. Okay. So when in our previous example, if we were to talk about equity shares value, so previously we assumed the investors required rate of return, RR, IRR. This is what the investor wants, right? This is the required rate of return, in internal required rate of return. So there are two securities. One is 10% and another is 12%. So when we say percentage, now by now you understand how percentage is calculated. And internal rate of return. So you have a limited amount of money, let's say $100. Which investment would you choose? And this depends. This 12% actually looks lucrative. Yes, 12%. Obviously, if you are uh, given a chance to have 10% or 12%, you will obviously go with the the 12% return. Yes, this makes sense. But when you think about this thing from a finance perspective, uh, now, since you know how the rate is calculated, which investment would you prefer now? Now, since you have understood how the rate is calculated, which investment would you prefer? So this shift in attitude, uh, why the shift in attitude? Because now you understand how this interest rate is calculated, and that's how this whole curriculum is designed, and that's how I want you to, that's how I actually want to deliver this lecture to you so that you understand a holistic picture. And please try not to mug up things. Mm, okay. Mm, so the required rate of return. So in practice, the required rate of return on equity is not directly observable. In the case of bonds, it was yes. But in when we talk about equity, the required rate of return is not directly observable because equity, if you know about equity, so the return is not certain. So return might be high, return might be low. So this is how actually equity looks like. And there are a lot of factors which influence this thing. So there are n number of factors here also. And we will discuss about this when we will discuss about equity investment. So there are n numbers of factors, and that's why internal rate of return is not observable in equity investments. Okay, so understand this thing and try to relate with this. So there are penny stocks, and there are blue chip companies, BLUE chip companies. Blue chip companies, the return is low. Okay, whatever, relow. The return is low, and here the return is high. But the fluctuation is also high. The fluctuation is also high. But when we talk about blue chip companies, the fluctuation is not very high, and the companies are growing stable. The companies are growing at a stable rate at a stable rate, basically, not a rate of. But so this is what this whole statement means that this IRR is not directly observable. So instead, we use share price rather than using this thing, the rate of return for IRR. We actually use share price, and that's why required rate of equity. When we talk about required rate of equity, we talk about dividends, not about percentage growth. Percentage, sorry, we there is growth, but we start from dividend. So if a company is stable and growing, the rate of return is calculating they calculate it using dividends. So dividend, let's assume the dividend is 10 here, and the next period the dividend is 12%, $12, $12 maybe. So this is actually uh, there is a 20% growth. Yes. So this is actually this is why the dividend is very important for an investor. So the history of dividends is very important for an investor. So, and this actually we can observe in market to drive implied required rate of return on equity. And given our assumptions that, I mean, given the assumptions about their future cash flows. So from this thing, this 10 to 12, I can assume this previously the company has been growing at a rate of 8 will be 8 would not be the right percentage, but let's assume that it grew. Uh, Let me just use my calculator. So the company grew here 25%. My bad. Okay, yes, 25%. The company grew at 25%, and here the company grew at 20%. Yes, I can do an averaging. Okay, I can average these things, but averaging would not be the right, and that's why we in the previous LOSs we talked about what is a arithmetic mean, what is geometric mean, and what is harmonic mean. When to use which mean, the importance of arithmetic, geometric, and harmonic mean. And this will actually help us. This will actually help us to assume the future cash flows. This will actually help us to predict the future cash flows. So that's what D1 is representing. Dividend next year based on. So this is dividend one. So next year the company is paying this much dividend. And how do we calculate this thing? This is time zero, D0, and this is D1. And based on the growth and the cost, this is KE means cost. So this is how actually this formula meets in theory. Okay, let me just make some space here first, and we will not be using this whatsoever we have written here. So we will not be using this. I think hopefully, or if we do, we will write it one more time. No problem. Okay, so implied rate of return. So if we assume a constant rate of return here, the rate of return is actually constant. Okay, no, not constant rate of return, but dividend. So if the rate of return is constant, let's assume this is constant. This is growing at a constant rate. And we talked about this in our previous LOS, where multi-periods, dividend discount model, multi-periods. Here we were assuming that the company is growing at a constant rate. If the company is growing at a constant rate, or if there is a sudden jump, let's say the company is growing at a constant rate and then there's a sudden jump and then the rate decreases. So we discussed about these things in our previous LOSs. So I hope that you are not able, you are not facing that much difficulty in connecting these things. Or if you are, then try to rewatch the previous LOS. So if you assume the constant rate of dividend growth, we can rearrange the constant dividend growth formula to this, the constant dividend discount model to solve for the required rate of return. And what we are going to do is we are going to move some things here to there. So we need to calculate. So, okay, so KE moves there to the formula. This is going to be here, and this V0 will come. in place of this D1 by V0. And what we need to do is we need to calculate the cost of equity. KE represents cost of equity. Cost of equity. And we will discuss about this thing in detail. Don't worry about this. Just understand the formula first. So the cost of equity. KE is the required return on common equity. So this is basically the cost. There seems this is a okay spelling mistake. So the required return on common equity. If the required return on common equity means uh, the stocks of your company, if as an investor I buy your stocks of the required returns, the stocks of your company, if as an investor I purchase your stocks, so I want this much return, KE, KE, this much return. Above this, it's good, but below this, it's uh, not acceptable. Yes, it's not acceptable. So KE minus growth, constant growth, dividend one, dividend at time one, and V0, and you can reverse engineer everything. So this will give you cost of equity as T1 divided by V0, and it add backs to GC. Now, so this is the required rate of return on equity, and the ratio. This is the ratio of expected dividend to the current price. Expected dividend to the This is the expected dividend to the current price. Value at zero. Current price. Value at zero basically. Current price here. And this is dividend at time one. And this is the dividend at time one means next year dividend basically. Understand this thing. You need to change this D1 to current price. Uh, you need to discount it back to a time zero. And always remember, you might have a tendency to make a mistake here. So now I am going to reshuffle the formula, and the formula is going to dividend at time zero, 1 plus growth. We value at time zero plus growth at a constant rate. The company is growing at a constant rate. And this is again GC. Okay. So we can rearrange the formula again when we want to calculate the growth constant, the implied growth rate, and we can move the other variables here and there. So this will give us the growth constant. And this is the implied growth rate and the required rate of return minus the dividend yield. This is the required rate, and this is the dividend yield. Dividend yield means you paid, uh, think about this. This is, let's assume that you paid 100 rupees for something, $100 for something, and the dividend next quarter is going to be uh, $15. So this, I am assuming that the the current year at D0, the dividend is actually $10, and the dividend grew by a rate of G is 50%. So this is actually will result into 15% dividend, $10. So 50% is the growth. How much did I mean, what is the implied growth? If we talk about implied growth, this is different. Okay, I mistakenly said C here. So this is actually different from the growth, implied growth. The required rate of return, let's assume the required rate of return was mm, so let's assume that, okay, let's not assume anything. I think this is going to give us a negative number. So this would be the wrong logic to apply here. So I hope you have understood what implied growth means and what does the growth means. Okay, so let's do some questions first, and so that uh, we are able to understand what is we are going to do. Um, let's apply this concept now. So question number 14. So this is going to start with question number 14 because the other don't worry about the sequence because we have previously done other questions and out of those, so this is 14, question number 14. Now, okay, question number 14 is using a constant growth dividend discount model, and analyst assumes a required return on equity of 9.7%. So using a constant growth dividend, DDM, the analyst assumes the required rate of return is 9.75. The required rate of return is 9.75. The current stock price is the stock price is the currently the stock is priced at 30 per share, and the next period dividend is 2.4. The next period dividend is 2.4. D1 is 2.4 per share. Required return on equity is 9.75. So this means required return the required rate of return is 9.75. The current stock price is 30. D0 is 30. Next period dividend is going to be 2.4. Growth rate implied in this model is closest to what? Simply plug in these numbers. GC growth constant is going to be cost subtract 30 multiply this with not 30, my bad. Let me just fix this. Uh, Dividend at time one is 2.4, and this is going to be divided by mm, 30. So once we calculate this thing, the cost is 9.75% minus 2.4 divided by 30. This is how actually we are going to calculate this. Once you plug in these numbers, first solve for 2.4, 2.4 divided by 30, and then solve the equation, and this is going to give you somewhat around 1.75% as an answer. So since you know the formula, you just need to plug in these numbers. This was not a tricky question, but yes, when you think, when you discuss about CFA. So there are tricky questions. Okay, my bad. Because here actually we were discussing that if it's 15 divided by 100, so growth is 50%. Yes, growth is 50%, but the growth is being divided by 100 also. Uh, then it's going to be somewhat around 50. The growth is going to be 100. So this is going to be 0.005. And let's assume if the investment is the required rate of return is 1%. So if you divide and you if you look at the GC here, so it's somewhat around the growth constant is the company is growing at a constant rate of roughly 1%, 10% only, but not 10%, but 0.995 maybe 9.95% now since this. Okay, so next question is an investor makes 48 monthly payments of 500. So 48 monthly payments of 500 beginning today. If they are saying 48 monthly payments, this is N, this is PMT into your account, that you will have a value of 2900 at the end of the fourth year. At the end of 4 years. This basically means 4 years, and this is 40. So 4 multiplied by 12 is 48. 48 is N, and this is actually, we will be calculating monthly payments. The into the account that will have a value of 29 at the end of the 4 years, and the stated annual interest rate is going to be what? Okay, now understand this. This is uh, this is the present value, not the present value. This will be the okay present value. Uh, 0. Future value is this. And when we talk about payments, PMT is $500. And N is going to be 48. So rate, which we will calculate here, the I slash Y, this is going to be a monthly rate. And at the end, don't forget to multiply this by 12. So let me just share my screen, my calculator with you so that you do not uh, get confused while doing these kind of questions. So let me just, okay, let me just clear everything. Here, the present value is 0 because you are actually investing $500 every month. So you are starting with present value 0. The future value is 29,000. So negative, I'm going to set as negative because uh, cash inflow and outflow. So negative doesn't represent inflow, or positive doesn't represent outflow. So just so that it's easier for us to calculate. So future value, this is future value. Payments is you are going to pay 500, and this is, I'm keeping this as a positive number. So this is an outflow, and we need to calculate IY, and the period is 48 now. N is 48. Now let's compute the IY here. IY here is 0.78, and this is actually a monthly rate of return. Monthly return. So what we are going to do is multiply 12. This is going to be, and again multiply this with 100 so that you can convert this into a percentage. So this is 9.4. So we actually have an option, 9.4. Now let's move to question number 20. The question number 20 is, you're assuming a constant growth rate of in dividends, and we can estimate an equity. Assuming a constant rate of growth in dividends, so we can estimate an equity shares what? Constant rate of growth in dividend. We can estimate, what are we going to estimate in equity shares using this information? Understand the question first. So constant growth rate means growth rate is constant. Growth rate in dividend is constant. So they also said dividend. And since they said equity shares, so this formula should come to you. Using this information, we actually calculate either cost of equity, either growth. Two things we can calculate. So either we, okay, let's go through the examples. Go through the options here given to us. So required rate of return is actually the required rate of return as the sum of dividends, dividend yield and growth rate, sum of dividend yield. This is even dividend yield and growth rate. First, this seems okay. Growth rate as the sum of dividend yield, growth rate as the sum of even growth rate as the sum of dividend yield. Now understand what they are saying. So the question is saying, the option is saying growth rate as the sum of dividend yield. Dividend yield is V1, D1 divided by V0, and required rate of return, KE. But if I move this thing here, if I move this thing here, this is going to be a negative now. This is going to be negative. So this should not be positive, but it should be KE minus dividend yield. And there are going to be questions where they will give you dividend yield. So it's important to understand this means dividend yield D1 slash D1 divided by V0. This is dividend yield. Yield means return. Dividend yield means now you are paying 100 rupees for something which will be next year valued at uh, $15, hypothetical example. And dividend yield means basically uh, 10 multiplied by 1 plus 50%, which is the 10 multiplied by 50%, $10 and divided by 100. So this is how much actually I will be receiving next year if I pay this. So dividend yield. Understand what does dividend yield means. And the third option here is, so this is negative, and the dividend yield here now. The third option is dividend yield D1 slash D1 divided by V0 as the sum of required return KE and its growth rate GC. If I move the formula here, this is again going to give me G D1 slash V0, D1 divided by V0. This is going to give me similar result, KE minus GC. And in that case also, the option we are eliminating option C also. Okay. Now question number 26. And let's quickly just do this question number 26 now. And how much questions do we have? We have actually few more questions, uh, which we will discuss in our next reading. So an analyst is using a constant growth dividend discount model DDM to evaluate stock XYZ. The stock is currently being traded at $20. Currently being traded at $20. and has recently paid an annual dividend of $1.50, assuming a constant growth rate of 4.5%. So growth rate here is 4.5%, and the implied required return of the stock we need to calculate. So KE, cost, we are going to calculate. So again, we will go to the formula here. Understand the formula. V0 is D1 divided by KE minus GC. V0 is D1 divided by KE minus growth C. Dividend at time 0 is 1.5. It's growing at a rate of 4.5%. 1 plus 4.5%. And since I'm saying percent, don't forget to divide it by 100. Don't use both of these, percentage and 100. So divide this by 100. First, this thing. Then divide it by KE minus G. And this is going to be equal to 20. This whole equation is going to be equal to $20. Solve this, and the answer is 12.34, and the rest of the questions we will do in next day. Thank you for attending this, and I hope you have found some value. Thank you.